Good morning, class. Welcome back. So we'll be doing exercise 12.3, section B, question 1 to 3. So the first question that we have here is this: find the area of the shaded region in figure. This is the figure which is given to us. Okay. That is the figure which is given to us, and it is given that PQ. Okay, this line, this PQ, is how much? 24 centimeter. Okay. And PR, that is this straight line, you see this is actually a straight line, okay, that is 7 centimeter. So in fact, if this is a straight line, then this will be, since this is a straight line and this is another straight line, they will form a 90-degree angle. So the triangle would look something like this, okay, it would be Q, P and R. So this is 7 centimeter, this is a 90-degree angle, 24. Mind you, okay, see, because PQ is a straight line that cuts the point P. So because of that, this is going to form the angle 90 degree. Now this becomes a right angle triangle, right? Because why do we need to find out QR? We need to find out QR because we want to know the radius of the given circle. Okay, we have to find QR. Clear? We have to find QR because if we are able to find out QR, we'll be able to get the radius. Therefore, in right angle triangles, okay, right triangle QRP, we use Pythagoras theorems. By Pythagoras theorem, we get it as hypotenuse square equal to, right? So hypotenuse in the case of this is going to be the hypotenuse square. Hypotenuse, this area is going to be perpendicular and RP is going to be the base, okay? So QR square equal to QP square plus PR square. We already know the value of PQ or QP, okay? You could just name it anything you want. QP is 24 centimeter square, right? 24 centimeter. PR, that is going to be 7 centimeter whole thing square. Okay, clear with this? And we're going to find out QR. We don't know what QR is. So 24 square is 576 centimeter square plus 7 centimeter square is going to be 49 centimeter square. So when you add these two up, you'll be getting this as 625 centimeter square. Okay, therefore the next line, QR square, QR square is equal to 625 centimeter square. Oh, sorry, it's 625 centimeter square. So you take the square root to the other side, okay? So the square root of this is going to be 625 centimeter square. So this is going to be 625 is 25 square centimeter square. So you can cancel out the square. So you'll be left with 25 centimeter. Now what have we got? Our QR. That means we already have QR is 25 centimeter. Okay. So here I'll write it here. QR, we got it as 25 centimeter. But if you pay attention to it, QR is formed by what lines? This is C, Q and R, okay, another straight line out here. Q and R is formed by the lines RO plus OQ, okay, is equal to 25 centimeter. Clear? This RO, and when you add these two lines, you'll form QR. All right. Therefore, you can assume or say divide it, okay. Therefore, you can write. Now since these are equally divided, okay, we already know that since this is a straight line, okay, remember OQ and OR are what? They are the radius of a circle, and the radius of a circle anywhere you take for that matter, okay, does not matter. You take it here you want, you take it here if you want, but you take it anywhere from any angle, it is going to be equal. So in the sense, since OQ and OR are both the radius of a circle, they are going to be equal. Clear? So OR is going to be equal to OQ. So we'll add them up, okay? So I'll write this as OR plus OR. You'll get it as 25 centimeter. So 2OR is going to be equal to 25 centimeter. So OR is equal to 25 centimeter by 2. And what is OR? Remember, OR is the radius of the circle, okay? Radius of circle, okay? So we have everything that we need. We have the radius of a circle, okay? Now, we are asked to find the area of the shaded region. So we are asked to find the area of this region, okay? So in order to find the area of this region, what we can go about is, if we're able to find the area of this circle, okay? So if we're able to find out the area of this circle, okay? This is the area we're supposed to find, okay? So if we're able to find the area of this circle and subtract it with this area of this triangle, right? Then we will be able to get the area of the shaded region, okay? Clear with this? If we calculate the entire thing, all right, and subtract this area of this region, then we will be able to get the area of this shaded region. Therefore, area of the shaded region is going to be equal to, of the shaded region is equal to, not the area of the, not the area of the entire circle. It's going to be area of the semicircle. You look at this, okay? Let me just rub that off. It's quite messy. So here, okay? See, now we have a proper, okay? So what is this circle from this area to this section is the area of it's a semicircle, right? So if we take the area of a semicircle, or you can call it a half circle, and subtract it with the triangle, what do you get? You'll be able to get the area of the shaded region, okay? Therefore, area of the shaded region is going to be area of semicircle minus area of a triangle, okay? So when you do that, you'll be able to get the shaded region, okay? Clear? So I have taken, I'm assuming, okay, sorry, it's here, okay? We have to take it from the other side, but more or less it's the same. This is the area of a semicircle, okay? From this section to this section, okay? This is the area of a semicircle, and I'll be subtracting, after taking the area of the semicircle, if I subtract this triangle, then we'll be able to get this shaded region, alright? So what is the area of a semicircle? It is pi r square by 2. Area of a triangle is half into base into height. Now you already know the radius, which is 25 centimeter by 2 into 25 centimeter by 2 minus half. Now when you look in the triangle, this is a given triangle, so it's very easy for us to point out which is the base, 7 centimeter, and what is the height, QP, right? See, this QR cannot be the height, right? Because imagine if you're standing, for us or for anybody to calculate your height, you have to be standing straight. Only then you'll get the exact approximation of your height. So because of that, since this is a straight line, this is considered the height of the triangle, and this line is called the base. Clear? So the base is going to be 7 centimeter and the height is given as 24 centimeter. So you can cancel this. 2 into 12 is 24. Then you can replace your pi with 22 by 7, okay? 22 by 7 into 2 into 25 by 2 into 25 centimeter by 2 minus 84 centimeter square, because there are 2 centimeters here, okay? Now you can cancel this out, so you'll be left with 11 into 25 centimeter into 25 centimeter divided by 7 into 2 into 2, okay, minus 84. So you really don't have to, you multiply this, okay? So this will be 25 into 25, 625. You'll have to do the calculation yourself, okay? 625 centimeter square divided by 28 minus 84 centimeter square. So this is going to be equal to 6,275 centimeter square. Take the LCM, clear? Let me just proceed with one more step. So if you take the LCM, since this does not have anything with it, what are you supposed to do? You're supposed to multiply 28 to it, right? So 6,275 centimeter square. So this will give you 6,275 centimeter square minus 2,352 centimeter square divided by 28. So that is going to be equal to 4,523 by 28 centimeter square. So this is your answer. Okay. Next question. This is a very, okay, I hope you have noted it down. You just paused the video and watched it. So the next question, this is given, okay. So you look at this. What are we asked to find? We are asked to find the area of the shaded region. So when you look in the diagram, the first thing is you will have to identify where your shaded region is. So it will be this, okay, this colored, this is the area of the shaded region. All right, now when you read the question carefully, okay. So we're asked to find the area of a region. Now if radii, okay, what is radii? It means radius only, okay. It radii of the two concentric circles. There are two circles in this given graph. Can you see two circles? This is one circle and this is another circle. With the radius of these two concentric circles with center O, this is the center O, are 7 centimeter and 14 centimeter. So very easy for us to find. Obviously, they are saying one of the circle has radius 7 centimeter and the other circle has radius 14 centimeters. So obviously the smaller circle will have the smaller radius and the bigger circle will have the bigger radius, right? It's just simple logic. So you just look at this. This is our given area. We're asked to find this area, okay. Now this is from 0, C, A and B and D, okay. So this area, this is OB or OD, these are both 7 centimeter because this is the radius of the smaller circle, okay. I'm just separating out. Now from O to C, this is 14 centimeter. The same thing for this, O to A is 14 centimeter. Clear? So we're asked to find the area of this. So if we take the area of this bigger circle, remember this is actually not a straight line, it's a slight curve, okay. If you just pay attention, see, it's a slight curve, right? It's not a straight line. So if we take this area, find out the area of this entire region and subtract it with this region, so we will be left with this region, right? So therefore we have, let's say the smaller radius, I'll take it R1 and the bigger radius is R2. And another important essential information is given to us, which is the angle AOC, okay. So what is AOC? This is theta, okay. So this angle is given as, angle AOC is given as 40 degree. You can replace this as theta is given as 40 degree. Why should you replace this? This is because if you look into this diagram, it looks like a sector, okay. This is a sector, right? In the previous exercises we have done, this is a sector. So in sector, whenever an angle is given, we substitute directly that as theta. Therefore, we are going to find out the area of the shaded region, okay. So area of the shaded region, like I said, it is going to be equal to area of the bigger sector first, okay. See, I take this area of the bigger sector. So area of the bigger sector of the big sector, let's just go with that, minus, if I take the area of the smaller sector, remember a sector looks like this, okay, like a pie, like a pizza, right? When you slice it out, it looks like that. So this is, let's say, the big sector, and let's take the smaller one as the smaller sector, okay. So area of the smaller sector, clear, of the small sector. So I hope you have not forgotten the formula of that. The area of the bigger sector is pi r square, yes, theta divided by 360. This is bigger sector, so the bigger sector obviously means the bigger radius, okay. And then this area of the smaller sector is going to pi r1 square theta by 360. Now let's just replace it. Replace your pi with theta, and you look at this given. Okay. You look at this. What is common to both? Pi is common to both. Yes. Okay. If you carefully see this, pi is common to both. 360 is also common to both. What else is common? Theta is also common to both. So you're left with r2 square minus r1 square. Okay. Yes or not? Okay, because pi is common, both has pi, so you can take it out. 360 is present in both the case, so you can take that out. Theta is there in both the case, so you can also take theta out. Okay, clear? So replace your pi by 22 by 7 into 360. Your theta is 40 degree. Now r2 square is going to be 14 centimeter square. Okay, minus your r1 square is going to be this, the smaller scale is going to be this, okay. So you can just cancel this, 4 0 0 cancels, 4 into 9, so 22 by 7 into 9, so this is going to be 14 square is 196 centimeters square, this is going to be 49 centimeters square. So you'll be left with 22 by 7 into 9 into 147. Now you do the calculation slowly. 7 7c, 7 2s are 14, 7 1s. You can just do this, okay, in case if you're confused. So take this, 7 2s are 14. What is left again? 7. 7 times 1 is 7. So that's how you get. Now this is going to be 3 times 3 is 9. 3 times 7 is 21. So this is going to be centimeter square. Don't forget that, okay. So 22, because see, when you subtract 196 minus 49, you get 147, but centimeter square remains, so you have to write centimeter square again. So 22 into 7 is going to be 154 centimeters square by 3. Clear? One easy way to understand when you're finding out with this SI unit is, remember, we're asked to find the area, okay. So whenever you're asked to find the area, your unit, your SI unit, we call this a unit of measurement, this should always be in terms of centimeter square. If it's meter, meter square. If it's millimeter, millimeter square. Clear? It will always be expressed like this. If it's area, okay, this will happen when you ask for area, okay. And when it's for volume, it will be in terms of cube. So centimeter cube, meter cube, millimeter cube, okay. So centimeter square means you're multiplying centimeter 2 times, and that's how you get centimeter square, okay. This is also the same thing as square centimeter, okay. See, square centimeter is also correct, centimeter into centimeter is also correct, centimeter square, this is also correct, okay. It's just different notations. The last question for this video is going to be this. We're going to find the area of the shaded region. Now this is a very easy one, okay. We have to find this area only, okay. So now they have given us that the A, B, C, D is a square which have side 14 centimeter. Another important property of square is all the sides are equal. So all of these sides are going to be equal. Clear? Now what is given again? A, P, D. Where is it? A, P and D are, and B, P, C are what? They are semicircles. Okay? They are semicircles. Clear? So this is the circle. Semicircle means half circle, okay. This will form it this way. So you have P, A and D, and you have P, B and C, okay. Now what is AD? AD is given as 14 centimeter. AD is given as 14 centimeter. Clear? So what is AD again? In a semicircle, what would AD be? So solution, you start with this, okay. So this is given, AD is equal to 14 centimeter, but in semicircle or any circle there is a radius, yes or not? Yes? Clear? So AD serves as AD and BC are the diameter of a semicircle or diameter of a circle, okay, of a circle, okay, they are the diameter. Clear? In the circle, this is the radius, okay. But if you draw a straight line like this, and this becomes the diameter, okay, diameter. Clear? So the diameter of a circle is 2r, and what is the diameter of this circle is given as, so AD is the diameter of the, I have given you as the diameter of the circle, so this is equal to 14 centimeter. So the radius is going to be equal to 14 by 2, that is radius is going to be equal to 7 centimeter. This is the radius. So we have everything that we need, okay. Now you just think, if we want to find out this shaded region, what do we have to take? We first have to find out the area of the square, is it not? Yes. So when you take out the area of this square, and then so you get everything, and then you take out area of this semicircle and another semicircle. Obviously when you take area of a square and subtract these two semicircle, what would you get? You'll be left with the shaded region. See, you just look at this, you take the area of this entire circle. When you take the area of this entire circle, you're including all these areas, okay. It includes everything, it includes this white portion, everything, this blue portion, okay, when you take the area of a square. Clear? So now you want to remove this area, right, this circle area, this semicircle area, okay. so it looks like a half moon. Okay, so you want to remove this because we are asked to find the shaded region. So if you want to remove this, you have to subtract this from this entire area. After that, you'll be left with this. Okay, so let's go. Area of the shaded region is going to be equal to area of a square minus, okay, area of a square. Clear? See, so what happens is, when you take area of a square, all of this is included. Okay, this is area of a square. You're going to include everything. Clear? Now you're going to subtract. So from this area of this square, what are you doing? You are subtracting what? 2 semicircles. If you subtract this, okay, see, if you subtract this, what are you left with? Look at this. And subtracting this, so you look at this. Yes, so see, this is what you get. I took the area of a circle and I'm subtracting this area of a semicircle. Okay, so when you do that, you'll actually be left with the shaded region only. So that is going to be this. Okay, see, so how many semicircles do you see? There are 2 semicircles, so that means you have to subtract 2 semicircles. So 2 into area of semicircle. Okay, clear? See, I'll tell you what happens. Okay, you take a square, and then if you subtract only 1 semicircle, then you subtract this part, then this part will be left out. Okay, but the question is, we only have to find the shaded region, so because of that we have to also remove the other semicircle. Clear? Be careful with that. Okay, if you subtract only 1, you'll be left with, if you subtract only 1 semicircle, then you'll be left with this part. Okay, this area. So we have to subtract 2 areas, 2 semicircles, only then we'll get the shaded region. Area of a square is length into length, or side square. So that is going to be 14 centimeter square. Okay, side square. 2 into area of a semicircle is pi r square by 2. Semicircle. Okay, area of a circle is pi r square, area of a semicircle is pi r square by 2. It is pi r square by 2 because we are only considering half of that circle. Okay, so cancel this. So 14 centimeter square is 196 centimeter square. Pi is going to be 22 by 7, and r square is going to be 7 centimeter into 7 centimeter. So you can cancel out 7 from here. So 196 centimeter square minus 22 into 7 is going to be 154. Centimeter into centimeter is centimeter square. So 196 centimeter square minus 154 centimeter square is going to be 42 centimeter square. And this is your answer. Okay, we will end the video here, and we will do the next question in the next video.